All right, people. Happy Monday. It's time to get back to doing some math. Hopefully, you had a great weekend. You didn't go around and do any crazy socializing. You just stayed low key. Maybe went outside, had some fun, got some fresh air, talked to some friends, did all the good things you're supposed to be doing. Today, what we're going to do is we're going to start doing adding and subtracting of rational expressions. Just a reminder, rational expression just means like a fraction with letters, right? So we're going to add and subtract fractions with letters. Honestly, today's not going to be too bad. It's just the only thing that happens is we're going to now start to get a lot of rules, right? So we have the rule of NPVs from the first lesson. Then we have a rule of multiplying. Then we have a rule of kissing and flipping when you're dividing. Now we're going to have rules for adding and subtracting. And then we're going to get rules for the next lesson and the next lesson. You're going to notice these rules start to really pile up. So your practice time is going to be important here. Make sure that you go back and you practice previous lessons and current lessons. So like mix up what you're practicing so that you start remembering all the rules for all the different situations. Before we start adding and subtracting these crazy rational expressions with all these letters, we're just going to add and subtract some basic fractions. So if I had this and I had 2 over 3 plus 3 over 4, and I went to add those things together, we couldn't do it. And the reason we couldn't do it is because it needs something. It needs a common denominator. That means that the number on the bottom has to be the same number. If they're different numbers, you can't add and subtract fractions. The way we get a common denominator is by finding the lowest common multiple between two numbers. So when I look at 3 and 4, I try to find the smallest number they could both multiply to become. So for instance, if I did 3 times 4, it would become 12. If I did 4 times 3, it would also become 12. So the lowest number it could ever become is 12. We're going to get that by multiplying the first one by 4. And we're going to get that by multiplying the second one by 3. Now, the rule in math is that we always have to balance things, right? So you can't just multiply denominators to get new numbers and not balance it. The way we balance it is by whatever we do to the bottom, we do to the top. So when I multiply the bottom by 4, I have to multiply this top by 4. On the other side, if I multiply the bottom by 3, I have to multiply the top by 3. And that balances out what we're doing to our question. So this now becomes 8 divided by 12 plus 9 divided by 12. Cool. You had to get a common denominator. Once you have a common denominator, you are going to add the numbers across the top and the bottom stays the same. So for instance, if I picture these as measurements, right? Say I have 8/12 of something, maybe 8/12 of a pizza. And then I have 9/12 of something. If I had 8/12 plus 9/12, I would have 17/12. Right? The bottom number doesn't change. The top changes because now I have a different amount of them, but the bottom number is telling me the size of something I have. So this becomes 17/12. It doesn't become 17/24, which is what sometimes people do. It's 17/12. We look up here, we'll do another one. You look at your two denominators, you realize you have to get them to be the same number. I can actually turn 5 into 20 if I just multiply by 4. What I do to the bottom, I do to the top. So that gives me 12 over 20 minus 9 over 20. And again, like I think of this as 20ths. So I have 12 20ths minus 9 20ths. That means I would have 3 20ths. Right? Because 9 or 12 minus 9 is 3, and it's 20ths still. This last one over here, the common denominator on this one would be 18. Right? If I multiply 9 by 2, it would be 18. If I multiply 6 by 3, it would be 18. What I do to the bottom, I do to the top. So this becomes 3 over 18 minus 14 over 18. Again, we think of this as 18ths. So we have 3 18ths minus 14 18ths. I would have negative 11 18ths. That's adding and subtracting, and that's all we're really going to do today. We're going to add in some letters, so it might get a little bit more confusing, but this process of common denominator and then combining the two fractions is all we're going to be doing. We will skip a couple slides, like we're going to skip this guy. to try to reduce the size of these videos for you, give you more practice time. So we get to this question on the test. All it says is simplify. The first thing you always want to do is factor. You can't factor that, obviously, because there's no additions or subtractions. Then you want to state your non-permissible values. Non-permissible values are things that cause you to divide by 0. This could turn to 0. If x equaled 0, 3 times 0 squared would be 0. That means x cannot equal 0. Cool. Now we can simplify this thing. Our first goal in simplifying is to combine this into one fraction. To do that, you must have a common denominator. When I look at this, I'm going to look at the numbers first. I'm going to do it the same way I was doing the questions above. If I have 3 and 2, the smallest number they both could become is 6. So I'm going to multiply the first one by 2, top and bottom. And I'm going to multiply the second one by 3, top and bottom. Then I'm going to look at the letter on the bottom, and I'm going to do the same thing. So the first fraction has an x squared on the bottom. The second fraction has no x squares, so I need to multiply it by x squared on the bottom. And what I do to the bottom, I do to the top. This will give me 10 over 6x squared plus 3x to the power of 3 over 6x squared. And you can see we successfully now have a common denominator. When you have a common denominator, you can just add the top. You have 10 plus 3x cubed. Those are not like terms, so we just write it out from biggest to lowest. We go our biggest exponent to lowest exponent. That becomes 3x cubed plus 10 divided by 6x squared. And that is my final answer. Here's how I know it's my final answer. I can't factor it. And I can't simplify. Well, I should also say it's one fraction, right? I've written it as one fraction. That's important. Sometimes people do this mistake where they say, oh, x cubed and x squared can cancel out. The reason that's a mistake is, remember, that is a binomial on the top. Binomials are in packages. So that means the only way I could simplify that 3x cubed plus 10 is if it canceled out with another 3x cubed plus 10, which it can't because there isn't one of those on the bottom. So that is a done question because I can't factor and I can't simplify it. Cool. If we go over here, my non-permissible values, you should be practicing those, would be x and y both cannot equal 0. Cool. Now, let's try to simplify this. Our first goal is to write it as one fraction. We can't write it as one fraction until we get a common denominator. I start with my numbers. 6 and 15 can both become 30. The first one would have to multiply by 5, and the second one would have to multiply by 2. I then move on to my letters. I have an x on the bottom, an x squared on the bottom over here. That means I need to turn the first one into an x squared somehow. I do that by multiplying by x. And what I do to the top, I do to the bottom. Then I'm going to look at the y's. The first fraction has a y. The second denominator has no y's. So I need to multiply it by y, bottom and top. This now gives me 5x divided by 30x squared y minus 4y over 30x squared y. And we've successfully got ourselves a common denominator. When you successfully have a common denominator, you can add or subtract the top. So this becomes 5x minus 4y. And the bottom stays the same. So it's 30x squared y. I am now completed because I have one fraction and I can't factor and I can't simplify that thing. Remember that the top is a binomial. It's in brackets. Cool. That's adding and subtracting monomials. So not terrible today. We go down here. There's 2 questions for you to practice. So pause this video and actually pause it. Don't be like, yeah, pause it, and then just try to finish the video on time. Like, don't be that guy. Go pause it. Try these on your own. You have the time. Then unpause it. See if you get the right answer. If you don't have the right answer, then come back and listen to my explanation on how I do it. Okay, look at this first one. I stated the NPV. NPV is x cannot equal 0. The first thing I need to be able to add and subtract these is a common denominator. The 7 and the 3 can both become 21. So I have to multiply this one by 3, this one by 7. I then look at the letters. This one has no x's on the bottom. This one has one x on the bottom. So I need to multiply this by x so that both fractions now have an x on the bottom. This gives me 6x squared divided by 21x plus 35 over 21x. Since I have a common denominator, I can now add and subtract the tops. It becomes 6x squared plus 35 divided by 21x. I know I'm done because I can't factor that top, right? No way I'm factoring that. And I cannot cancel out that binomial with anything. Cool. This one. I go and I get a common denominator by looking at the numbers.
Sorry,
Both.
I don't understand.
Well, my Google says it doesn't understand the math. I hope you're understanding better than my Google that's talking to me. I multiply the first one by 4 to make it 20.
I don't know how to help with that. There are other things you can try.
Google keeps interrupting my lesson here. It thinks it knows more than me. I multiply the first one by 4, top and bottom become 20. I multiply the second one by 5, top and bottom become 20. I then do the letters. The first fraction has an a. That means the second fraction needs to be multiplied by a because it doesn't have one. Then I look at the b's. The first one has a b. The second one has a b squared. That means I have to multiply the first one by b to get it to become b squared. This gives me 16 b's divided by 20 ab squared minus 15a divided by 20ab squared. Because I now have a common denominator, I can combine this to be one fraction. It is 16b minus 15a divided by 20ab squared. That is completed because I cannot factor it, and I cannot cancel anything out because that top thing is one big binomial, right? Awesome. We're crushing it. We're going to look at these ones, so it's going to get a little bit harder. The only reason it's going to get harder is if you look at the top is now binomials in these questions, where the top of these fractions were monomials. It's the only difference. So, first things first. First step is always factor. In the factoring step, I'm going to do something else important. I'm going to put brackets around my binomials. And the reason I do that is it's always good to remember that those things are kind of packaged up, right? And I don't do crazy things and start multiplying funny or canceling out funny. Brackets kind of protect me. So in that first step, when I factor, I also just put brackets around things I can't factor. My second step is state my non-permissible values. X cannot equal 0. Cool. Now, just like the previous questions, we're going to get a common denominator. We're going to look at these numbers first. I have 4 and I have 6. They could both multiply to become 12. I do the first one by 3. 3 times 4 is 12. And I do the second one by 2. Like that. I then look at my letters. I have an x squared here and an x here. So I'm going to multiply by x top and bottom. All right. I now have 3 times x minus 2 on the top of this binomial divided by 12x squared. The second binomial is now 2x times x plus 6 divided by 12x squared. Ta-da! Okay, My goal was to get a common denominator so that I could then add the tops together so that I had one fraction. The problem is I can't add those tops right now, and I can't add those tops right now because those brackets exist. So in order for me to be able to add the tops, I'm going to have to multiply these numbers in to the brackets. So I'm going to have to multiply the 3 in, and I'm going to have to multiply the plus 2x in. This will give me 3x minus 6. And on the blue side, I will have positive 2x squared plus 12x. And my denominator can now combine to become 1. So we had to multiply the tops so that we were able to actually add and subtract them. That's new to us. So in the previous lessons, remember, we didn't actually multiply the tops. We always just left it in factored form. The difference is I could not add and subtract the top values unless I was expanded. So I had to multiply. Then I can collect like terms. 3x and 12x can go together. The 2x squared is on its own. The minus 6 is on its own. So this top now comes out to be 2x squared plus 15x minus 6 divided by 12x squared. And I've successfully taken that question and I have rewritten it as one fraction by getting a like denominator and then adding the tops. I know I'm done the question when I can't factor and I can't cancel anything out. So if I look at this, I might be able to factor this top up here. So I need to try. So I quickly draw a little diamond and I say, okay, I want to multiply to be negative 12 and add to be 15. Are there any numbers that would work? The answer is no. No numbers would work. That means I can't factor. I also can't cancel anything out because this trinomial is like one big package. So this is my final answer. Because I can't factor and I can't cancel anything out. Cancel? C-E-L? C-L-E? C-L-E? Maybe Google is smarter than me. Okay, Google, how do you spell cancel? I think it's E-L.
Cancel is spelled C-A-N-C-E-L.
Oh, see? It is C-E-L. I don't need Google. Never mind Google. It's okay. I didn't need you. There we go. Let's try one more together. Then you're going to be off on your own. So the first step is factor. I can't factor anything in this question, but what I can do is I can put brackets around those binomials so I remember they're together. My second job is to state my non-permissible values. Both A and B cannot equal 0 or I'd be dividing by 0. Awesome. Now, let's get at it. So we need to subtract these two things together. To subtract these, we get a common denominator. We're going to look and we see 2 and 9 could both become 18. So I multiply this one by 9, top and bottom. Multiply this one by 2, top and bottom. Then I look at my letters. I have A squared and A. This one needs to be multiplied by an A to make it A squared. I look at my B's. This one is B. This one is B squared. I need to multiply the first one by B to make them both B squared. And this gives me 9b times 2a plus 1 from the first fraction. The second fraction is going to be 2a times b minus 3. And our common denominator will be 18a squared b squared. And I've successfully gotten a common denominator, which means I can add and subtract the tops, but not until I expand the tops. So when I expand, there's going to be something important about this question versus the previous question. I'm going to take this 9b and I'm going to expand it in, which is fine. Now that's going to work out just perfect. It's going to become 18ab plus 9b. It's the next expansion that's going to be different. I'm not multiplying 2a in. I'm multiplying negative 2a in. So make sure that negative goes into the brackets, and it becomes negative 2ab and then positive 6a. So always make sure when you're subtracting fractions that you multiply the negative to everything on the top. The denominator gets rewritten as just one denominator. Because we've expanded on the top, we can now collect like terms. 18ab and negative 2ab can combine. The 9b and the 6a cannot combine. So I'm going to write my answer out as 16ab plus 9b plus 6a. You can write that in any order you want, but those should be your three terms. And the denominator is 18a squared b squared. I know I'm done the question because I cannot factor that top and I cannot cancel anything out because remember that top is one big package. It's one big trinomial. It can only cancel the other trinomials. All right. That is adding and subtracting fractions. Not bad, right? Not crazy. There's 2 questions for you to try, and then we're going to be done. We're not going to do these slides. Again, trying to kind of reduce the amount of craziness we have in these videos. So pause the video, try your best, come back, unpause it, see how you did, especially on the second one. The second one's trickier. Cool. I'll rip through these fast. First things first, factor. I can't factor, but I do put brackets on the top. I also state my non-permissible values. My non-permissible values are x cannot equal 0. To get my common denominator, 8 and 6 can both multiply to become 24. So I'm going to multiply this one by 3 and this one by 4. I then look at the x's. This one's x squared. Multiply this guy by x, and that'll make both of them x squared. Whoa. Multiply this one by x. And both will become x squared. This gives me 3x multiplied by x plus 5. This gives me 4x minus 7. And the denominators are 24x squared. Like that. Perfect. Our goal is to write this as one fraction. The only way we can write it as one fraction is if we expand the top, right? That way we can collect our like terms. So we're going to expand our tops to become 3x squared plus 15x. And this one becomes plus 4x minus 28 divided by 24x squared. Across the top, I can combine like terms. It becomes 3x squared plus 19x minus 28 divided by 24x squared. I know I'm done if I can't cancel anything out and I can't factor. If I look at that top, I need to try to factor it. So the 3 times 28 gives you 72, I think. 84. Holy man. Maybe I should use my Google. So it's negative 84 on the top, positive 19 on the bottom. That's a tricky one. You might need to try a few combinations here, right? So 84 and start dividing it by things. Divide by 2 wouldn't work. 84 divided by 3, maybe 3 and 28 doesn't work. 84 divided by 4, 4 and 21 doesn't work. 84 divided by 6, 6 and 14 doesn't work. 84 divided by 7, 7 and 12. Oh, 7 and 12 looks like it might have potential because 7 and 12 does add together to be 19. However, I need to multiply to be negative 84, which means one of those values has to be negative. So this still doesn't work. 84 divided by 8 doesn't work. 84 divided by 9 doesn't work. And I've now tried all my numbers. Nothing can go in these spots. Therefore, this question is complete. Beautiful. This guy. First step, put brackets on things and try to factor. Second step, NPVs. C and D cannot equal 0, or I would be dividing by 0, which is no bueno. Now, get a common denominator. 3 and 5 become 15. This one has to multiply by 5. This one has to multiply by 3. C and C squared. This one needs to multiply by C. D and D, fine, don't have to multiply by anything. This gives me 5C times 3C minus 2 divided by 15C squared D. The second one will be 3 times C plus 8 divided by 15C squared D. And I successfully have a common denominator. Hopefully you got that part right. The part where people mess up is when they expand their top. They do a good job with the 5C to become 15C squared minus 10C, but they don't do a good job with the negative 3. Make sure the negative multiplies in as well to become negative 3C, negative 24. It's the 24 that people usually miss, so make sure you have negative 24. Because I've expanded, I can now collect like terms and write this as one fraction. My final answer is 15C squared minus 13C minus 24 divided by 15C squared D. Again, you should try to factor the top. It doesn't work. You can't cancel anything out because that top is one big polynomial. You can only cancel with one other big polynomial. Hoorah, what a Monday. Hopefully you guys are going to have a great day and a great 4-day week because you got no school on Friday. Keep kicking butt. Hopefully, if I reuse this video, you might have school on Friday. So let's pump the brakes a little bit. And it might not even be Monday if you're listening to this video on, say, Tuesday next year. Sucks to suck, but in my class right now, you guys, no school Friday. That's December 4th. What's the date tomorrow? December 7th, 2020. You guys, you don't have school on Friday. Everybody else, who knows when you got school? Sucks to be you. Take care of yourselves. Hopefully chat with you soon.